Let's have a look. There's our transformation there. So this time it makes the function f to the graph y equals x squared. So this time we're starting with some function f of x equals I don't know, and we end up with f of x equals x squared. So this is my final result. So this is my, if you like, we're saying y dashed is equal to x dash squared. That's my new function. So from my matrix, I can see that x dashed is equal to x plus 5 and y dashed is equal to y plus 0. This is my y dashed and x dashed already. So if I just substitute those in, I'll get y is equal to x plus 5 all squared. Now we can see that the only one that's close to that is option A. So being as studious as I am, I've had a quick check of the notes, and it seems that there should have been a negative one there in the question. So the question wasn't copied it out properly. So that's the answer we get. If we put the negative 1 in as we suggest, that negative 1 would mean that goes there, which means we would have a negative sign there to match off with the answer in the question. But x plus 5 all squared is the answer that our question has. So there's a little bit of a typo there. Let's go to question 2. The point 4, negative 3 lies on a graph of a function f. So there's our point. It is some translation seems to be applied to it. So we get the point 4, negative 3. What happens? The graph of f is translated 4 units vertically up. So vertically up means the y value increases by 4. So we get negative 3 plus 4, which is positive 1. Reflected in the y-axis, so in the y-axis is about that way, so my x value changes sign, so we get negative 4, 1. There, the coordinate of the final image is negative 4, 1, so that's the point A. Okay, not so bad. What about the next one? A transformation given by that maps a line with the equation onto, so this one's sort of applying in the order that we expect. So my new x point is given by negative x plus 1. My new y point is given by 2y minus 2. If I rearrange those, I'm going to have positive x equals 1 minus x dashed. And I'll have positive y is equal to y dash plus 2 over 2. So there's my x and y values. Let's substitute those into the equation I've been given. So I get 1 minus x dashed minus 2 times the y value, which is y dash plus 2 on 2 equals 3. So what does that leave me? That gives me a 1 minus x. 2's cancel there, so I'm going to get minus y minus 2 if I multiply that in. To leave me with, we'll get minus x minus y equals 1 minus 2. So let's take those across. So I end up with 5 minus 1, which is 4. Let's make all the negatives positive. I don't need to. That matches off to C straight away, doesn't it? So there's my new function there. What's our next one? Okay, so this one's actually a short answer question worth 3 marks. We need to find A, B, and C. So the transformations applied there. A curve with equation 1 on x is transformed according to that into this form here. So again, it's a straightforward application of it. So let's work out our x dashed is equal to, so 2x plus 1. Y dashed is equal to 4y minus 3. Rearrange, because that's x dash and y dashed equals, I need y equals and x equals. So what does x equal? X will equal, take 1 across and divide by 2. Y will equal y dashed plus 3 over 4. So they're the two values I'm going to substitute into my rule. So y dashed plus 3 over 4 is equal to, whoops, that's y. So my bad. I'm going to substitute those into there, aren't I? Into that equation equals 1 over x dashed minus 1 on 2. So let's just keep that here for now. I'm going to flip the other side upside down because I'm dividing by a fraction. Multiply 4 across. 2 times 4 is 8 over x minus 1. I can leave the dashes. So y is equal to 8 over x minus 1 minus 3. Now, we need to actually physically say what A, B, and C are. So matching those off, we can see that A is equal to 8. B, that's plus B, so B is equal to negative 1. C is equal to negative 3. Doesn't hurt to put a box around your final answer so that highlights it to the examiners.